We're going to write equations for the addition of acid or base to an HNO2 KNO2 buffer. Buffers are stable against the addition of an acid or a base to them, and you can add an acid or base to them without a significant change in pH. This is why. If you add an acid to a buffer, and all acids supply H plus hydrogen ions, so we can think of that as adding an acid to the buffer, that acid is going to react with part of that buffer. So let's start by looking at what is making up the buffer. The buffer is made up of nitrous acid, HNO2, and a salt, potassium nitrite, that supplies its conjugate base. So that HNO2 slash KNO2 is simply notation showing the two parts of the buffer. And these are the two species in the buffer solution. This is a weak acid, and this is a salt. Now, the salt is going to ionize or break apart into K plus and NO2 minus ions. The potassium ion is simply going to be a spectator ion, and it's not really going to do anything. But this nitrite, you might notice, is the conjugate base of our weak acid. So the two components in our buffer solution are going to be the acid, nitrous acid, and the conjugate base, nitrite ion. And so if we add acid to the buffer, that acid, H plus, is going to react with one of these two components in the buffer, either the other acid or the base. The acid is going to react with the base part of the buffer, and so it will react with the nitrite ion. And when that reaction takes place, the acid will donate itself to the base, and we will get the nitrous acid. Now, if we add base to the buffer instead, then the next question is, what is the base going to react with? Is the base going to react with the conjugate acid part of the buffer or the conjugate base part of the buffer? I would expect it to react with the conjugate base or conjugate acid part of the buffer. So the base is going to react with the nitrous acid. Now, what typically indicates base? Base is typically hydroxide. And so that nitrous acid will react with the hydroxide. And in a Bronsted-Lowry equation, it will act as the acid, donating an H plus to the hydroxide, which will accept that H plus because it is a base. And the resulting products are going to be nitrite ion and water. So this would be the equations for adding an acid to a buffer or adding a base to the buffer. Let's look and see what pattern that we can see here. When we add acid to the buffer, that acid converts the conjugate base part of the buffer to the conjugate acid part of the buffer. Or if we add base to a buffer, it will convert the conjugate acid part of the buffer to the conjugate base part of the buffer. In either case, the added acid is consumed or the added base is consumed. And that's how buffers control change in pH.